This is problem 2.43 from homework assignment number 2. This is problem number 5. That problem reads, write the formulas for the following ionic compounds, starting with sodium oxide. Now we have in class not yet learned how to predict the charges of ions, so knowing the charge on the sodium ion and knowing the charge on the oxide ion is not something that you will be expected to be able to do for the test. The problem asks you to refer to figure 211 in your textbook, which is on page 54 in the new book and probably in that general ballpark in the old book. And that table will give you the charges of the ions, because we haven't learned how to figure that out ourselves. So if you look on figure 211, you will see that the charge on the sodium ion is a plus 1 charge, and the charge on the oxide ion is a -2. You need to know the charges of the ions in order to be able to figure out how they come together to make the ionic compound. Once you have their charges figured out, all that you have to do is figure out how these two ions come together to make a compound, or an overall compound, that is neutral, that has no net charge. So we're going to combine to make a compound with no overall charge. Because the sodium ion has a +1 charge, the oxide ion has a -2 charge, it's going to take 2 sodium ions to balance out the -2 charge of a single oxide ion. And this will give us a ratio of 2 sodium ions for every 1 oxide. Our formula will be Na2O. And again, this is going to give us an overall total +2 charge coming from both the sodium ions, and an overall -2 charge coming from the single oxide. And that gives us a compound that's overall charge neutral. Also in class, we talked about how the Crisscross Rule helps us predict these formulas as well. Once we know the charges, the magnitude of the charge on the oxide ion is the quantity of sodium ions that we have in the formula, and the magnitude of the charge on the sodium is the quantity of oxide ions that we have in the formula. Part B says to figure out the formula for iron sulfide, and it tells us that the iron ion in this compound is the iron 2+ ion. If you look at figure 211, you'll see that the iron ion can be either 2+ or 3+. The sulfide ion has a -2 charge. And again, we're going to combine these to have a compound that's overall uncharged. Because these have the same magnitude of charge, a 2+ with a 2-, they're going to balance each other out in a 1-to-1 ratio. So we get FeS. If you'd used the crisscross rule on this, with bringing the 2 down to be the quantity of iron, and bringing this 2 down to be the quantity of sulfide, you would have gotten FeS2, and that just needs to be reduced to its empirical formula. So it takes a little bit longer to get to the correct formula using the crisscross rule in this case, but we'll still get there. Number C is cobalt sulfate, and it tells us that it contains the cobalt 3+ ion. Cobalt is another metal that has ions with variable charges. And then the sulfate ion, it tells us, is SO4 2-. Sulfate is a polyatomic ion. It's something that we're going to learn about in class today, Wednesday. So we haven't quite come to them yet. But you treat this whole entire polyatomic ion unit as if it was just one particle. So we're going to deal with the sulfate ion the same way that we dealt with a sulfide ion or an oxide ion. We still want to combine them to create a charge-neutral product. The cobalt ion having a +3 charge, the sulfate ion having a -2 charge. This is one time where the crisscross rule is really helpful. So the crisscross rule tells us that we're going to need 2 cobalts, and we're going to need 3 sulfates, which we'll put inside parentheses. Give us a formula like that. 2 cobalt ions together are going to have a net +6 charge. 3 sulfate ions are going to have a net -6 charge, so overall it's neutral. And last but not least, we have barium fluoride. And again, taking a look at figure 211, we can see the charge on the barium ion is +2, and the charge on the fluoride ion is -1. We want to combine these 2 ions to make a compound that has no net charge. We're going to need 2 fluoride ions to balance out a single barium, which gives us BaF2. It has 1 barium ion with a total of +2, 2 fluoride ions, -1 apiece, for a total of -2. The crisscross rule would have taken us to this formula as well. 2 fluoride ions, 1 barium ion, BaF2.